We have seen the basic rules of lambda expressions, and as I mentioned, I can imagine you'd have to revisit that again. But some examples of lambda expressions might also help, which is exactly what we're going to be doing now. Here's the previous example again. X and y becomes x plus y. Let's have a look at some examples of functional interfaces that can be implemented with this lambda expression in IntelliJ. So guess what? This would be a valid implementation of our calculate method. Why? Well, we say x and y is input, which will be the values for a and b here, and it's going to return x plus y, which is in this case a plus b. So that would be of type int. Let's create a main method and show you how to do this. So what is important is that we specify the type, so that IntelliJ knows what we're going to be talking about. So let's just create a calculator C1, and here I'm going to say x and y becomes x plus y. We do need a semicolon at the end because it's just a Java statement. And as you can see, this compiles, and this is now an implementation of our calculate method. And we could go ahead and say c1.calculate, and now I can just specify two values, 3 and 5. And this is going to return 8. So let's actually wrap this in a system out statement. So that's going to print the result. So I'm going to run this code. And as you can see, it outputs 8. The lambda expressions use a simple arrow syntax to represent the implementation of a functional interface. So right now, we used x and y to specify the input parameters, and we made them return x plus y. Here's something else that we could have done, just to demonstrate you how the body works. If we would have said 42 over here, it would pretty much mean x and y becomes 42. That means that this always will be returning 42. Not very useful, but hopefully this is useful to explain you how this is working exactly. As you can see, the output is now 42. I'm going to change this back to x plus y. What's important to note is that the parameters need to match. So this is not a valid implementation because the calculate method only accepts 2 parameters. You can, however, call this whatever you'd like to call them. So I called them x and y because to me that makes sense for mathematical stuff, but you could call them a and b or something and something else. It would have worked, as long as it's a valid identifier. So how does it know this needs to be the calculate method? Well, that's because our type is calculator over here. And if we move back to calculator, you can see it only has one abstract method, and that's the key. Since it only has one abstract method, it knows that must be the method that we're implementing here. And the cool thing is, I can create multiple implementations. So let's create C2. And C2 is going to be x minus y. Like this. And then I can output the result of that one too. And then let's do, well, 3 and 5 again. And now we'll get 8 and negative 2. So lambda expressions can handle different types of method bodies. And that includes single statements, multiple statements, and void statements. In this case, we're returning an int, so it can't do void. But let's see one that does multiple statements. So we're going to create a calculator C3. And again, I'm going to say it's going to accept x and y. And now I open curly brackets. And I'm going to do just hello from the lambda expression. And I want to return a value as well. I'm going to be returning x times y in this situation. But since this is multiple statements, I need the return keyword again. And you can see now red squigglies on line 12. And this is because this whole thing is actually one line, that needs a semicolon at the end. In my head, I call this a JavaScript semicolon, but you don't need to do that. I mean, you might not even know JavaScript, but that's how I come to think of it. So let's go ahead and call this method. You can see we do this in the exact same way. So I'm still going to wrap this in a print statement because I want to print x times y. Again, let's use 3 and 5. And there we go. Let's run it. And you can see it prints hello from the lambda expression and 15 at the end now as well. Let's create another functional interface to show you some more examples. So I'm going to call it printer, make it an interface, make it a functional interface, and I'll give it a void print method. And let's say x accepts a string. So right now it's not returning anything, it's only accepting one value. Well, when it's accepting only one value, I can actually leave out the parentheses around the input arguments, but I can add them in as well. Both is valid. So let's go printer p1 equals, and then I could say s for string, arrow, and then let's just print a string with printer says appended. There we go. So now this is one statement, not returning anything. And as you can see, the s doesn't have parentheses around it, but I could go ahead and add them around it. It's valid too, but it's very common to omit the parentheses if you only have one parameter for your lambda expression. So let's go ahead and call it. And I'm going to say p1.print hello. The reason I don't wrap this inside a system.out.print line is because it's not returning anything. So this is not valid to put in a system.out.print line because we cannot return voids, which is what the p1 print is returning. So let's go ahead and run this, and you'll see printer says hello at the very end. And there you have it. Printer says hello. All right, let me show you one more example. I want to have a functional interface that has a method that doesn't take any arguments. So I'm going to call this one number provider. And it's going to be a functional interface, of course. And it's going to have one method, provide, that returns an int, but doesn't take any arguments. Let me show you how to implement this with a lambda expression. So this one is going to be of type number provider. Let's call it np1. And when it doesn't take any arguments, you do need to empty parentheses like this, then the arrow, and then you can just return any number. It could be a random number or just any number, or do some sort of calculation, use part of the time, I don't care, just return some int and you'll be good to go. And that's what this looks like. And we can call this as well. So you can go ahead and, well, I'm going to print this again so we can see the result. np1 provides, and that's just going to be printing 42. All right, I think that's enough examples for now. I can imagine you need to see a few more, or you need to try it yourself and maybe watch this video again. But next up, we're actually going to explore how we can use these lambda expressions as input for other methods. And from there, it's going to be quite interesting. So let's go.